So today we're just going to be talking about it as a unit rate. And when I say unit rate, what I mean most of the time is what we're going to use slope for is something like miles per hour would be a good example of unit rate, right? So one thing per another. We'll also see kilometers per hour. Okay. You could see like dollars per unit, something like that. So that's what I mean by unit rate. It's always going to be one thing versus another. That's when we're talking about slope. So the x-axis is something and the y-axis is something. So usually, like when we're talking about distance over time, x-axis is distance, y-axis is time. All right, that's what I mean by gradient as a unit rate. Okay. So that's really the big thing for today. What I want us to start with first is I've got this word problem here. This is going to be good practice for the graded assignment as well on Wednesday. But I want you to go ahead and just read through this. It's investigation number 6 from your textbook, if you'd rather read it in your textbook. But just go ahead and read through it and see if you can fill out the table, use technology to draw the lines. All right, you'll need to label your graph yourself here. Just label the axes and things. All right, but take a few minutes to work through this problem here and see where you're getting stuck or what you know. If you can get through it all, that would be great. All right. And like I said, this will be good practice for kind of our grade assignment that we'll have on Wednesday. So give it a shot. I'll give you a couple minutes to take a look at it now. Hopefully you've had enough time to figure out first how to fill out the table. So we're looking at Bikers Village, which charges 10 British pounds per week plus 0.5 per kilometer cycled. And Bike and Joy charges 20 British pounds for the initial rental plus 0.1 pounds per kilometer cycled. Now, when we fill out the table and we sketch the graph, I have the ability to use different colors. If you have colored pencils, I'd recommend doing that. Or whenever you're doing this with like just a pencil, make sure you label your graphs so that way we can tell which one's which. So like I said, I have the ability to do it with colors, but you might not have that ability, which is fine. But just make sure you can tell, hey, I'm doing 2 separate lines on here. One of them is Bikers Village, and one of them is Bike and Joy. All right, so that's just really important. And you could always put the equation itself on there too, but in this case we haven't written an equation yet, so nothing to do there. And then we ask some questions. Which of the 2 options is cheaper for 20 kilometers? Bikers Village is cheaper at 20 kilometers. And then which is cheaper at 40 kilometers? That's going to be Bike and Joy. Okay, and then when are they exactly the same? It looks like 25 kilometers right there. All right, 25 kilometers, the same price. And then which shop should Tommy rent from? Would his decision depend on the number of kilometers he will ride would his decision depend on the number of kilometers he will ride the bicycle? And explain. All right, so then just quick explanation of what's going on in the real world context, right? So which one should he rent from? Like he's got the bike for an entire week. So if he rides less than 25 kilometers, he should rent from one of them. He should rent from Bikers Village. And then if he rides more than 25 kilometers, he should rent from the other one. Bike Enjoy. All right, hopefully that's not too difficult for us at this point in the year to just really identify the real world context of the problem. These are the types of problems that you'll be asked on like an IB exam. They might be more difficult than this, but trying to put things into actual context. That's part of the key of the IB exam. Okay, and this is determine the gradient of the two lines. So that's keyword for slope. What were we able to determine for the slope of the Bikers Village line? So you do rise over run, right? So for example, we could say Bikers Village, you could say 10 over 15. Let's see. Actually, we'll do two different y points, two different x points, right? We'll say 17.5 minus 15 over 15 minus 10. And we'll get 2.5 over 5. So it looks like the slope of Bikers Village is 1/2 is what I'm coming up with. And I just did y values minus x values. All right, and we'll talk about this one a little more in a second here too. And then for the other one, 21.5 minus 21 over 15 minus 10. So you're going to get 0.5 over 5, which is really like 1 over 10. So one of these has a slope of 1/2, the other one has a slope of 1/10. Very small slope, very small change there. All right, which makes sense because it turns out the slope 1/2, 0.5, that happens to be the rate that we're being charged each kilometer, which makes sense. And then the 1/10, that happens to be the 0.1 that we're being charged per kilometer from Bike Enjoy. So that totally makes sense. And then what does the gradient of each line represent in the context of this question? That's what the last part's asking us to identify right there. It represents the price per kilometer, which is where gradient comes in at a unit rate, right? Price per something, all right? Or this per that, all right? In this case, it's price per kilometer. But that's an example of where slope is used to represent a rate of some sort. Slope is always going to be representing rates. Miles per hour, kilometers per hour, all right? In this case, it's price per kilometer, all right? That's what slope is really good for representing, okay? So our only other example today, it's kind of a long one, but not too bad. It's just Sean and Nicole walk every day without taking any breaks during the walks. Sean walks 4 kilometers per hour. So there's your rate right there. And this time it's kilometers per hour. Nicole walks 9 kilometers in 2 hours. So that's not a really good representation of rate because he's per hour and she's per 2 hours. So we'd actually want to do 9 divided by 2 here. And it's safe to say that she's walking 4.5 kilometers per hour. All right. And that would help answer the first part. How far is she walking in 1 hour? And now we can extrapolate that and fill out the rest of our table. So when Sean walks 4 kilometers in 1 hour in 2 hours, that means he's walked 8 kilometers. And in 6 hours, he's walked 4 times 6, which is 24 kilometers. Nicole, on the other hand, she would be doing 4.5 times 6. So 4.5 times 6, which is going to be 27 kilometers over 6 hours. All right. So the next part, graph the lines representing Sean and Nicole's daily walks on the same pair of axes, where X is the number of hours walked. So we'll label our axes number of hours. And Y is the distance in kilometers. All right. And in this case, when we're given a graph, we have to determine what do we want to use for our axes. This is probably not the best graph for the representation. Probably would have been better just to work in quadrant 1 here. But since they're both starting at 0, 0 here, start with Sean in red. All right. And we're just talking about like 4 hours, 6 hours. We can probably count by 1 hour on this axis. So we'll count 1, 2, 3, 4, 5 hours, 6, 7, 8, 9, 10 hours. And then for kilometers, we get up to 24 kilometers by 6 hours. So maybe we'll count by 3s on kilometers, 3, 5, 10, or 3, 5, 9, 12, 15. That's how we can determine our axes, like kind of how we're going to use this best for our scale. If we're using a calculator, it's always good to check our viewing window and determine what's a good way to look at this line. So Sean, in 1 hour, he goes 4 kilometers. And then in 2 hours, he went 8. In 6 hours, he went 24. 18, 21, 24. And that's how we can determine Sean's kilometers. Nicole started at 4.5 after 1 hour, so just slightly above Sean. And then she was at 9 after 2 hours. And by 6 hours, she was all the way up to 27. So not a huge difference. But that would be the difference between the two. And then again, maybe label them. Here's Nicole. The red one is Sean. That way I know which one is which. That'll be important on your graded assignment when you're working on that you make sure you label these properly. All right. And then determine the slope of each line. And we already talked about how slope is going to be the slope is always going to be the rate. So in this case, Sean's slope is 4 kilometers per hour, and Nicole's rate is 4.5. That's her slope. All right. And then part B says Nicole gives Sean a head start of 1.5 kilometers. So instead of him starting at 0, like he does down here, he's going to start at 1.5. They're both walking the exact same rate. So what I want you guys to do is go ahead and fill in the new table for Sean and Nicole. And then to determine the number of hours it'll take Nicole to catch up with Sean after she starts her walk. Okay? And then how will you determine this from the graphs on the line? Be careful when you're picking your axes to make sure that it sketches nicely and looks like it's going to fit. But maybe the table will be more helpful here, or if we're graphing on our calculator, it might be a little more helpful. The problem with graphing on the calculator is we still don't have an equation yet. We're going to talk about how to write those equations more tomorrow. All right. But then we determine the number of hours it'll take Nicole to catch up with Sean. I can see that on the table. It'll take 3 hours. All right. And then how would you determine this from the lines? From the lines, it's the intersection. It's the point of intersection. That's simple. Okay, so I mean, we talked a lot about slope on Friday. Today, we're just really looking at it more from a real world perspective, putting a face on it. That's the only difference from Friday to today. And